Good morning, friends. Today we are going to continue the next part of this particular unit. In the last lecture, we discussed about the reactions of the organometallic compound, especially the reagent. Same way, you can write the reaction for the organolithium compound. We have seen the reaction of the Grignard reagent with the compounds containing acidic hydrogen atom. Then we have seen the reaction with the carbon dioxide. Then we have seen the reaction with the carbonic compound. Then we have seen the reaction with the cyanide. Then we have seen larger reaction with the epoxide. We have seen this particular reaction with suitable examples. You can try for the more number of examples for your practice on your own. Today we are going to discuss reactions and reactivity of alkyl halide. This particular alkyl halide undergoes the nucleophilic substitution reaction. What is the nucleophilic substitution reaction? It is nothing but the replacement of one group by nucleophile. It's called as the nucleophilic substitution reaction. Example is over here, hydrolysis of methyl bromide using the base. Example is nothing but the hydrolysis of methyl bromide using the base. You can take base either KOH or NOH. When this particular methyl bromide is nothing but the CH3Br, react with KOH as a nucleophile, at that time, what will happen? This OH group will act as a nucleon. It will replace this Br, and Br will come with the K, that is the CH3OH plus KBr. It will gives you the methanol plus KBr. What this point substitution reaction means? You have to just replace one group by the nucleophile. Here nucleophile in the KOH in the base, KOH or say NOH, there is a OH is the base, means OH will replace Br. It will give you from the alkyl halide, that is a methyl bromide will give you the methyl alcohol or say methanol. This nucleophilic substitution reaction at a saturated carbon can be classified on the basis of their mechanism. There are the three types of the mechanism: SN1, SN2, SNI. SN1 mechanism or say SN1 reactions are nothing but unimolecular nucleophilic substitution reactions. SN2 reactions are nothing but bimolecular nucleophilic substitution reaction. SNI is nothing but the internal nucleophilic substitution reaction. First of all, we will see in this lecture especially the SN1 reaction mechanism. This SN1 stands for, I already said you, the unimolecular nucleophilic substitution. Though it is a SN1, but it proceeds in two steps. First step is the slow step, and which is a RDS, means the rate determining step. In short, it is called as the RDS, and involves the ionization of reactant to form the carbocation as an intermediate. What is there? First step is RDS, means rate determining step, where the formation of the carbocation takes place. Second step is the fast step, in which nucleophile attacks on the intermediate carbocation to give the final product. Rx plus OH minus gives you ROH plus X minus. How this reaction proceeds, that we will see. First step is the formation of the carbocation. It is a slow step. Rx, on arrow you have to write the slow. In the square bracket you have to show the partial bond breaking. That is, a partial charge will be there on the R and the X. R delta plus dot 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 X delta minus. This is a transition state. It is a highly unstable state. It will gives you the formation of the intermediate carbocation R plus X minus. In the step 2, nucleophilic attack on the carbocation means R plus OH minus will gives you. It is the first step. Intermediate product will be the R delta plus dot 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 OH delta minus. It is a transition state. Second gives you the final product ROH. Are you getting this point? What happened in the step 1? Formation of the carbocation. First step is the formation of carbocation. What happens? This Rx will dissociate as R plus and X minus. That is a carbocation. Then on this in the step a nucleophilic attack will take place on this carbocation. It will give you the R plus OH minus, gives you the formation of the ROH with this along with these two transition state second. Kinetics of this reaction. SN1 is a first order reaction because rate of reaction depends only on the concentration of the substrate molecule and does not on the concentration of nucleophile. Therefore, rate expression is written as rate is equal to K in bracket Rx, where K is equal to rate constant. Example is given: hydrolysis of tertiary butyl chloride using base. Hydrolysis of tertiary butyl chloride using base. In bracket it is given KOH, or either you can take the water also. You know water is having amphoteric nature, that is it may be the acid or say base. Means you can take either the water or say this particular thing. Hydrolysis is there. Tertiary butyl chloride. Sometime the name of that IUPAC name of this particular compound will be given. What will be the IUPAC name of this compound? 2-chloro-2-methyl propane. Okay, this particular name of the compound will be there. What will happen? Just there will be the Cl will be substituted by the OH, and you will get tertiary butyl chloride will give you the tertiary butyl alcohol. Now, first step, formation of the carbocation. Again, same thing we have to apply over here. Take this CH3, CCH3, CH3, Cl. This is the slow step. This is the TS1. In that, what will happen? This bond will break. Means partial. You have to show partially this bond. Here, delta negative charge will be there, and here delta positive charge will be there. Here delta negative charge will be there. Then it is a highly unstable state. It will give the formation of the carbocation, tertiary carbocation plus Cl minus. CH3C, CH3, CH3 plus charge plus Cl minus. In the second step, there will be the nucleophilic attack on the carbocation. You can see here CH3, CCH3, CH3 plus OH minus. This is the first reaction, will gives you the partial bond formation in the transition state. It is a highly unstable. It will gives you the formation of this particular tertiary butyl alcohol. Got this reaction? What is there? When you take this example, tertiary butyl alcohol, tertiary butyl chloride, first step will be the dissociation of this bond, means formation of the carbocation will be there. How that carbocation will be there? This C will carbon will get the positive charge, and whereas this halide ion will get the negative charge. In the second step, there will be the nucleophilic attack. OH minus will attack on this particular carbocation and gives you the formation of the alcohol. Then EPD, energy profile diagram, that we have to see. See, when we are taking the reactant, they are at the highest energy, then the product. Then this reactant undergoes the reaction which gives you the transition state 1, which has the higher energy than the reactant. Then it again comes back by releasing energy, it gives the formation of the carbocation. Then this there will be attack of the nucleophile on this carbocation, again goes to the transition state 2, which is highly unstable. And it comes back to the very lowest energy, giving a product. This line you have to touch over here, because the difference between this change in energy of the reactant and the product is nothing but a delta H, whereas this energy, this you can see this energy between this particular reactant and the transition state is nothing but the energy of activation. E1 and E2 has been shown there. Now you got this particular diagram. This EA is nothing but the energy of activation. Okay, there will be the two EAs, because one is especially, first of all, reactant is going to the TS1 to give the carbocation, and this on this carbocation there will be the nucleophilic attack. Again it goes to the transition state and gives you the back the final product or desired product by releasing the energy. The difference between the energy of the reactant and the product is nothing but a enthalpy delta H, energy of that heat of reaction, you can call it as. Okay. Now we have to talk about the stereochemistry of the SN1 reaction. Ionization of this particularly optically pure alkyl halide molecules lead to give the planar or chiral carbocation with an NP orbital. MDP orbital perpendicular to the plane. Addition of nucleophile can take place at both the side of the carbocation with the equal extent, resulting in a 50% inversion of configuration and 50% retention of configuration. Gives you the formation of racemic mixture or racemates. What happens? When there will the nucleophilic attack on the carbocation. It will take place from the both the sides by giving 50% inversion product and 50% retention product, combinedly called as a racemic mixture or racemates. Here you can see this example has been shown to you. You can take any example. Same also you can take. Here C6H11CHHCH3 is shown there. Then what will happen? This OH minus this OH minus may attack from front side or say back side. That has only you have to show. Here CH3 should be there. Okay, from back side or say front side. Means what is the inversion? When this particular OH minus will attack from the side opposite to this particular leaving group. What is the leaving group? Br will nothing but the leaving group. Okay, and the coming group will nothing but the OH minus nucleophile. In this particular case, what will happen? Nucleophile will attack from the front side as well as the back side. Means back side means the side opposite to this particular leaving group, and same side. When this OH group will attack on the same side, then it will give you the retention of the configuration. When it will attack from the back side, then it will give you the inversion of configuration. This is the stereochemical point of view. There will be the formation of the racemic mixture of racemates with the 50% of inversion of configuration and 50% of retention of configuration. You can take any example over here. Not necessary to take this example only. You can see attack has been shown. A is nothing but the back side attack, B is nothing but the front side attack. Okay. You can modelize it things. When backside attack will be there, at that time H will shift to this side. Okay, and here you can see this example. Getting this point, what will happen in the stereochemical point of view, how that reaction will gives you the formation of this particular, what we can say, formation of this particular configuration. Okay, it will gives you the this particular racemates or racemic mixture. Means racemates or racemic mixture is nothing but the 50% of inversion of configuration and 50% of retention of configuration. Got this point? It is about the SN1 reaction. Then we have to similarly talk about the SN2 reaction. This is the energy profile diagram. When the particular example is asked, at that time see, you can write directly with the help of this example. Then kinetics of the reaction is necessary. Okay, then energy profile diagram and the stereochemistry of the reaction. 5 marks question it is. What is there? 5 marks question it is. There will be the question of 5 marks. What you have to write in that? Either you can write down the general reaction, or say you can take the suitable example. First of all, you have to write these things, okay? Then take the example directly, or say you can take the general. Write their mechanism. First step is the formation of the carbocation. Second step will be the nucleophilic attack on the carbocation. Then you have to write down the kinetics of the reaction. Then draw the energy profile diagram. Then discuss the stereochemistry of the SN1 reaction. There is marks for these things. Okay, please write this structure for this particular stereochemistry of this particular reaction. How the 50% inversion product will be there, and how the 50% retention product is there, that you have to show by drawing the example. You can take the tertiary butyl alcohol also, not necessary to take this example. You can take any example and you can show that particular stereochemistry of this particular reaction, SN1, especially the SN1 reaction. Okay, very simple it is. Please practice it well, please prepare it well. If you are not getting it, then you can ask, I will explain you again. Okay, today we will stop here. Thank you.